Now we're starting section 4.8, where we're going to look at some of the applications of using trig functions to draw triangles and then find missing angles. The two most common situations for these are called angles of elevation and angles of depression. An angle of elevation is when you draw a horizontal line out from your viewpoint, and then you draw a second line looking up at an object above you. The angle in between those is what we call the angle of elevation. Similarly, you could draw a horizontal line coming straight out of your field of vision, and then a second line looking down at an object, and we would call that an angle of depression. So a lot of times my favorite part in these examples is just drawing the figures. So I encourage you to draw a diagram. It does help with laying out the triangle. So for example, on this one, we have Harry Potter, riding the broom, and there's a golden snitch that is described as an angle of elevation from him, so it has to be up above. Now they told us that the angle of elevation from Harry to the golden snitch. That means if we draw our triangle in here, the angle inside of that triangle for him looking up at the object compared to the horizontal line is going to be the 43 degrees. Now they also say that it is 30 meters above him, so they're describing a vertical distance, which means it has to be this side of the triangle. And what they're actually asking us is how far does he have to fly horizontally? So that would be the left and right motion for him to be exactly underneath that golden snitch. So in this case, we want to figure out which trig function is going to define the relationship given to us here. We have an angle, we have the opposite side, and we're looking for the adjacent side. Most angle of elevation and depression questions are going to come down to the tangent function. So tangent of 43 in this case will equal the opposite side over the adjacent side, which is what we're interested in. So in this case, I would multiply both sides by x and then divide both sides by tangent of 43, and that would give me x equals 30 over tangent of 43. Now, since 43 degrees is not one of the measurements we can find on a unit circle, we have to do this one with our calculator. So you would just carefully type in 30 divided by tangent of 43, and make sure you are in the correct mode. Of course, you want to make sure you're in degree mode for these. It's uncommon to do them in radians. So the answer I got was 32.17. Something else I'd like to point out here is we could also figure out the angle of depression from the golden snitch, because from the golden snitch's point of view, he's looking down at Harry along that same diagonal line that we're seeing from Harry up to the golden snitch. And so if you look back at the comment I had in the last slide, the angle of elevation from one object is actually equal to the angle of depression for the other. So what I'm saying is Harry's angle of elevation is the same as the snitch's angle of depression. So those numbers right in here where the red arrow is, that would also be 43 if we'd wanted to work out the figure that way instead. For this next example, we're still doing an angle of elevation or depression. Specifically, we're going to compare the angle of elevation we just did to an angle of depression question. So what we're given is that there is an X-wing in pursuit of a TIE fighter. If you don't recognize those terms, that's fine. These are just Star Wars ships. So we have an X-wing so that's one ship, and it's looking down at another object in the distance. The second object is a TIE fighter, and we're told that the angle of depression from the X-wing to the TIE fighter is 23 degrees. So again, the important thing on the setup is that you have a horizontal line coming out of the object that's looking at the other object. So the protagonist, or the main subject in this case, is the X-wing. So his line has a horizontal one coming out of it, and then he's looking down at the other object. That's what creates the angle in here. And the length they told us is that the X-wing is 50 meters above him. So again, the vertical distance in this case is 50 to describe that vertical height. So how far ahead is the TIE fighter horizontally? So again, my relationship for a given angle to the opposite side and the adjacent side is going to be tangent. So I'm going to say tangent of 23 degrees is equal to 50 over x. I usually like to use x for the horizontal lengths and y for the vertical ones. And to solve this, I would need to multiply both sides by x, and then since I'll have x times tangent of 23, I'm going to divide by the tangent of 23. So this will be x equals 50 over tangent of 23 in our calculators. Please make sure you are still in degree mode. You shouldn't have to switch back and forth much in this particular section. They didn't say what to round to specifically, so I'm going to leave this as approximately 117.29 meters. Always be careful about whether the directions specified to the 100,000th for rounding. I'm trying to leave the units out for this, and I'm just using a generic rounding for now because sometimes the questions will change with how many decimal places they want you to use. This next example is a slight complication on the last ones we looked at. So we have a tower, and in this tower we have a person looking down in the distance. And this person happens to have very long hair. So I'm going to set up one triangle for the first time she looks out at the horse, which means we're going to have a vertical distance. She's in a 20-meter tall tower, and she's looking out at the horse running in. And the angle for the first time she looks at the horse is 14 degrees. So we want to figure out what the horizontal distance is from Rapunzel to the horse. And again, you'll see that from our angle, we have the opposite side and we're looking for the adjacent side. So I'm going to write tangent of 14 is equal to opposite over adjacent. And if we solve that, we'll have 20 divided by tangent of 14. So I'm getting a horizontal distance of approximately 80.22 meters. And then if we use our same diagram, but we change the angle a little bit. So now she looks back at it later on, and the angle's gotten a little bit bigger because the horse has gotten closer. So the horizontal distance wouldn't be quite as far, but the vertical distance should still be the same. So for this diagram, I need to solve tangent of 19 degrees is equal to opposite over adjacent. So again, x is going to end up equaling 20 divided by tangent of 19. And I'm getting a length of approximately 58.08 meters. Now, like I said, when we're comparing our two figures, what's happening is the horse is running a horizontal distance between the one time she looked out the window and the second time she looked out the window. So that's why the angle is getting steeper, which means that the horse must be closer to the tower than it was. So as far as how far the horse traveled between the two times she looked, well, we could take the distance the horse was away from the tower the first time and subtract the distance the horse was away from the tower the second time. And we're getting an answer of 22.14. So it's distance away the first time minus the distance away the second time shows us how far the horse has traveled in between those two intervals. Another popular twist that they do on questions is they sometimes have the object's viewing point situated somewhere above the ground. So in this case, we have a bench being described. And on this beautiful bench right here, we have a cat that is looking off towards a squirrel in a tree. So the angle of elevation from the cat to the squirrel, again, since my point of view is coming from the cat, the horizontal line needs to extend from that object. The angle of elevation is 52 degrees. And they tell us that the cat is 5 meters away from the tree. So they're describing the horizontal distance there. And they want us to find how high above the ground is the squirrel. Well, I'm still going to set up my tangent of 52 degrees. Is equal to opposite. This time the side I don't know is the opposite side, but I do know the adjacent side. So my solving is a little bit different this time. I just need to multiply both sides by 5. So I'm getting 5 times tangent of 52, which is a vertical height of 6.40 meters approximately. But here's the trick. We didn't use this other fact over here, that the cat is 1 meter above the ground. Well, our triangle just found that the distance from the height to the height that the cat was at, the height of the squirrel to the height the cat was at, was 6.4 meters, but there's another meter of height because of the bench and the height of the cat itself. So what we actually need to do is take that 1 meter starting point and add it to this 6.4 meter starting point. So altogether, we're going to get a final answer of 7.4 meters. That would describe the height of the squirrel all the way above the ground. So be careful about some of the tricks that they sometimes throw into these angle of elevation and depression problems. You might need to either add or subtract a number. That's all for the notes. Thank you.